Okay, good morning, everyone. So before we get started, just a note, Dr. Larrick and I put quiz 4 up on the Canvas site. 15 questions. I think it's due next Monday at noon. So make sure you give yourself enough time to go through that. It covers blizzards, plate tectonics, earthquakes, tsunamis. So any questions on the quiz? Okay, so last class we were talking about trace elements in the environment, and it's a really different type of hazard than what we've been discussing so far. You know, when you think of all the hazards that we've covered, blizzards and earthquakes, tsunamis, these are big visual things. You can see these, they're impactful, they're out there, you can see them coming sometimes. This is kind of an invisible thing that's just out there all the time. I mean, it's happening to you right now. You're being exposed to trace elements in the environment, but our bodies have adapted through the millennia to be able to handle small amounts of this in the environment. But at some point, if you get too much of any of this stuff, for the most part, it can potentially be toxic to you. And we ended up the last class right here talking about how trace elements can behave in your body, and there's really 3 different ways. The first one is for a limited number of trace elements. Typically, these are the heavy metals, lead, mercury. Your body doesn't need these. There's no benefit for taking it. Your body doesn't use them at all, but in small doses, your body handles it just fine. So if you get a low to no dose, having some isn't going to help you, having some isn't going to hurt you, so you're not going to get any benefit or harm from it. They're just there. Your body can deal with it. But depending on how old you are, male, female, genetics, a lot of different factors, at some point you're going to reach a level of dosage in your body that's toxic. And the definition of toxic is it's going to start doing you some harm. If you keep increasing the dose from that point, you're going to be progressively more sick, and eventually you can die from this. So that's not for all trace elements, just for a select few. Lead and mercury are the 2 best examples. The second classification that we went through last class is for, again, a certain number of trace elements. Trace element that you absolutely need this to be healthy. But these tend to be water soluble, and since your body is mostly water, it will simply get rid of the excess and won't cause you harm. So because your body needs it, if you don't get any, you're going to have a deficiency disease. I use the example of vitamin C. If you don't get enough vitamin C, you get a disease called scurvy. If you don't want scurvy, get some vitamin C. You increase the dosage, it will be better for your health. But then at some point, more is not better. Your body can only handle so much, but the excess your body can get rid of. So you get the benefit, but taking more doesn't help you. And since your body can get rid of the excess, taking more doesn't hurt you either. Again, not all trace elements behave this way. It's a fairly small number. Most trace elements behave according to the last example. It's required. You got to have it or you're going to be sick. If you don't have it, you're going to have a deficiency disease. There's a certain amount that you want to get in your diet where you get a maximum health benefit. But in this case, if you take too much, you can get sick. It can be toxic. And you will see a decay in your health if you continue to increase the dosage. So things like iron, copper, trace elements like that, magnesium, a lot of things that you find in your vitamins fall into this category, okay? So even water, which is not a trace element, we don't measure water in trace amounts. You have lots of water in you, but it's an element or a molecule in your body that really behaves the same way. If you don't have enough, you're dehydrated and you're sick and you can die. If you get too much, you get hyponatremia and you get sick and you can die. So these other trace elements like copper, iron behave the same way. So the goal for you as a person is to get the right amount of trace elements, not too little, not too much, But how many of you get up in the morning and think, oh, God, I got to get the right amount of trace elements today? You don't. I know about this stuff, and I don't. What do? We try to eat right. We try to eat healthy so that we get a good balance of all this stuff in our diet. That's maybe what we do. We might not think about this directly, but that's the point of trying to have a good diet. So how does geology, earth science, relate to this potential medical field? Well, one thing geologists are concerned with is how the environment works. And one of the aspects of that is to identify and measure potential sources of these trace elements in the environment. Identify areas that may have excessive amounts of these trace elements, things like lead or mercury or radon. Identify them so that the health community knows that in this area, this is a potential threat to people. Or if there's an area that doesn't have enough of an essential trace element, so that the food grown in that area may not be sufficient to cover the needs of the people that eat it, and they'll have to go somewhere else to get some of that trace element. We'll talk more about that in a minute. So that's the role that geologists have in this aspect of medicine. So how do these trace elements get into our body? We mentioned this a little bit last class. You can get some of it through the air you breathe. Our oxygen, or our air, what you're breathing right now, is mostly nitrogen. Your body really doesn't need nitrogen. So you breathe it in, your body doesn't need it, it doesn't pick it up, you breathe it back out. So most of that breath of air that you breathe in isn't really doing anything for you. In that same breath is about 21% oxygen. That's the mother lode, that's the money maker, that's what keeps you alive with every breath. But then there's other stuff in the air besides nitrogen that you don't need and oxygen that you do need. There's things like sulfur gases, carbon dioxide, carbon monoxide. Think of carbon monoxide, something that we are concerned about. You get too much of this in your home, you can suffocate, you can die. We have carbon monoxide detectors now in most homes and buildings. But we only measure it in trace amounts in the environment. So you can get some of this through the air that you breathe. And one of the ones we'll talk about here shortly is radon. I mentioned it last class, and we'll talk about it here shortly. Your water is more than just H2O. It's mostly H2O, 99-point-something% H2O, but there's other stuff dissolved in the water. And water that you get here in Greeley, let's say you pump it out of the ground from a well, is different than the water you'll get in Fort Collins, different than the water you'll get in Miami, different than the water you'll get in Delhi, India, because water dissolves different things in different areas because it moves through different kinds of rocks and soil. My water in Fort Collins is what we call hard water. Hard water means that it has lots of the stuff dissolved in it, lots of calcium, lots of magnesium. That stuff crusts up pipes. You'll see sort of this white deposit on your pipes. That's the minerals that are dissolved in the water. But some of those can be really good for you. Calcium is a common trace element in hard water. And do you guys need calcium in your diets? What does calcium do for you? Yeah, that really has two main sort of functions in your body. One is to promote good bone growth. The other is it's really important for your cardiovascular health. Your heart will not function properly without enough calcium. Same with magnesium. So these are actually good things. Yeah, it sucks for your pipes and that, but it can actually be good for your health. So we get some of these things through the water we drink, the air we breathe, but the vast majority of these trace elements comes from the food you eat. Plants and animals. Veggies and meat. But a head of lettuce grown in California is actually going to be different than a head of lettuce grown in somewhere in the Midwest, say Iowa, or in the deep South, or Ecuador, because you have different rocks and soils in those areas. The plants are growing in the soils and they're getting their nutrients from the soils. So they're getting different kinds of nutrients in each of these different areas that have different soils. Some of these soils may be really rich in copper. That lettuce will be richer in copper than lettuce that's grown in soils that are poor in copper. So if you're eating those vegetables, your trace element intake is dependent on the rocks and soils that the plant grew in. If you're eating meat, your trace element is dependent on their trace element, and their trace elements are dependent on the food they're eating. So what this means is that the trace element makeup of your diet is very tied to where you get your food. So your trace element intake is highly dependent on the rock, soils, and how the land is used in an area. But it's much less dependent on this today than it was 100 years ago. So 100 years ago, where did people get their food? If people were living here in Greeley, where did they get their food? They grow it, or they got it from local markets. They got it from the area, right? Where do you get your food today? You go to King Soopers, right? And you pick an avocado up. Where's that avocado from? Might be from Ecuador or Mexico. And then you're going to go over and get some onions, make guac or something. The onions might be from Texas. And you pick up an orange from California. And you pick up some corn from Iowa. You're getting trace elements from all these different areas. You're actually getting a better blend of trace elements today than maybe 100 years ago. Because let's say you lived in this area, and let's say this area was really poor in iodine in the rocks and soils. You wouldn't be getting any in your diet. And you could suffer a trace element deficiency disease really easy. Now you get a really nice mix of trace elements from all over the world. Just because of the way we've changed our way of procuring food from the supermarket. So again, your trace element intake is dependent on the rocks and soils in the area, but probably less so today. Interestingly, there's a push today to eat local, right? To eat local markets. And that has some advantages. You get more food from small farms that may be doing their farming with less chemicals, less pesticides, less herbicides. You're supporting the local economy. But if you go totally back to a local source of food, then you have to realize that you're only getting a local source of trace elements. And you might be deficient in some. Now, luckily today, we can counteract that. You simply take a multivitamin, which has lots of trace elements in it. So you can sort of counteract that. But you have to be conscious about doing so. Okay, any questions so far? All right. This is, you don't have to write this down, obviously, but it just shows that different types of rocks, you have the rock type listed on top from left to right, peridotite, basalt, andesite, rhyolite, phonolite. These are just igneous rocks from around the world. And then over here we have various trace elements: silicon, titanium, aluminum, iron, manganese, magnesium, and so on. And all this chart is showing is that depending on the rock type, you're going to get different amounts of this in your rocks and soil. Look at magnesium here about halfway down. Peridotite, ridiculous amounts. 30 times what you'd get if you lived over a phonolite. So if you're living in an area that has this peridotite rock type, you're going to get a lot of magnesium in your diet. If you live over phonolite, you're not going to get much at all. So all this is saying is that the rocks are kind of the ultimate source of the trace elements for our food. Rocks break down in the soils. Plants extract nutrients from the soils. farm animals eat the plants that extracted the trace elements from the soils, and finally they end up in your body. Yeah, Claire. Yeah, she asked, can you have an overdose? Can you hit toxic levels of trace elements just because of the rocks you live over? The answer is absolutely yes. And it actually happens just a little north of here with a trace element called selenium. Your body can use a little selenium, but it doesn't need very much, and it's toxic. So there's places up in western South Dakota and eastern Wyoming where the soils have really high levels of selenium. And there's a plant that grows in the soils up there that loves to suck up selenium. It just loves it. And then if you have farm animals and they come around and they eat that plant, they get super high levels in their tissue. Then if you eat it, you can get sick. And that's happened in that part of the country. Not so much people getting sick, but they're actually having problems with mutated farm animals, chickens that won't hatch, miscarriages with cows and sheep and stuff like that. So yeah, you can absolutely get too much trace element from the environment. With radon, one that you don't need, you can get too much of it right here. And in fact, depending on where you live, we'll talk about radon in a second, you might be getting too much. You might be suffering lung damage because of radon in your house. We'll talk about this in a minute and things you can do to check and see whether you are getting a lot of radon or not. It's something that's pretty easy to combat, but if you don't know it's there, you might not do anything about it. All right, here's some examples. Okay, this is just a list of 4 or 5 examples. There are more. I chose these because in many cases they're things that have happened fairly close to here, or they're happening today and they could be affecting you. That's one of our goals for this class, is to provide you with some information about hazards in the environment that can affect you all the time, like this, or occasionally, like blizzards and floods. So, the first example is about goiter. I showed you a picture of goiter at the end of the last class. It's a disease of the thyroid, and it's caused by a lack of iodine in your diet. Now, about 100 years ago, the northern part of the U.S. was known as the goiter belt. North Dakota, South Dakota, parts of Minnesota, parts of Montana. This area, prior to World War I, had really high incidences of goiter. If you go up there today, you don't see people with goiter. But you can go to other parts of the world and find folks that suffer from this. Again, it's a thyroid disease, and for your thyroid to function properly, you have to have the trace element iodine. And as it turns out, the soils in this northern part of the U.S. are very iodine poor. It's just not in the rocks. So it's just not in the soils. So it doesn't end up in plants and animals. And if you obtain your food only from this area, like we did 100 years ago, you simply don't get enough iodine in your diet. And for some people, in levels that are insufficient to allow their thyroid to function properly. But if you go up there today, you don't see people with it, because we fixed this problem, and it was really simple. We put it in something that everybody used. Even though people got their food locally, everybody still needs salt. And you'd have to go to the local market to get salt, even 100, 150 years ago. So the idea was, let's put iodine, which is tasteless, odorless, colorless, in small amounts, and let's put it in the salt. And that's the birth of iodized salt. That's pretty much all the salt that you get today is a little bit of iodine in it, and that was put in to combat goiter. So, easy. You're not getting it in the environment, let's put it in something that everybody uses. So That's where iodized salt came from, was to get rid of goiter. And again, goiter is not something you want. Disease of the thyroid, if not treated, can lead to growths and tumors. And yeah, this is not a disease that you want, especially when it's as simple as simply shaking some iodized salt on your food. If this person had had access to it, she wouldn't have this problem. Radon gas. This is the one, to me, this is the real reason why I teach this chapter. This is something I want all of you to know. So I don't know how many of you smoke. I'm not going to ask you. It's your business, your freedoms. You guys do what you want. My parents smoked. I did not smoke. I've never smoked. I've always been into endurance sports and fitness. I've tried to take care of myself. Smoking is just, to me, the antithesis of that personally, so I never go that way. I go out of my way to make sure my heart and lungs are in good shape. That's just a choice I have made. This gas, you can't see it, you can't smell it. It can basically undo the kind of lifestyle that I've tried to live. I've done everything to protect my heart and lungs so that they last a long time. Sadly, I'm getting up there in age. I'm getting to that age where I have to start worrying about this sort of crap. And I'm glad that I've done this through the years, but this stuff is scary. I'm going to scare you in the next few minutes. I really am. And I want you to be scared. I want you to take this seriously. So radon is this gas that's produced in the earth by the decay of uranium. Uranium is a radioactive element. It's not in the ground in high amounts, but in certain types of rocks, especially a rock called granite, which is a really common rock in mountainous areas. So if you go up into the mountains west of here, you're going to find a crap ton of granite up there. And granite naturally has higher levels of uranium than most other rocks. When uranium, which is radioactive, breaks down, one of the byproducts of that radioactive decay of uranium is a gas called radon, which is also radioactive. So this radon is produced in the ground. What does a gas want to do when it's in the ground? It's less dense than its surroundings, so where does it want to go? It'll go up. So it'll start moving up through pore spaces and cracks and crevices, and it'll wiggle all the way out of the ground, and then the atmosphere will come along and just blow it away. So it gets mixed in with the air. But we do things as humans to concentrate that gas. Yeah, question? Can you get radon from granite countertops? Yes, but it's so small of an amount that it won't matter. We're talking massive amounts of granite in the ground. And that's what granite countertops are. If you get true granite, it's just a slab of that, but it's thin, it's not very big. Yeah, you might get a molecule or two of radon that comes out of it. Won't be enough to affect your health though. But living over this stuff definitely will affect your health. So let's see how this works. You guys may have heard of this term half-life. It's simply a measure of how radioactive a substance is. Technically, it's the amount of time it takes for half of a radioactive substance to break down into something else. Now, for uranium, the half-life is in billions of years. It's a super slow process of breaking down. Radon does not, or uranium does not break down very fast. So in your granite countertop, sure, you've got maybe a little bit of uranium, but the half-life is so long that very little of it breaks down. Radon is the opposite, though. It's got a really fast half-life. 4 days. That's really quick. So you have uranium. Uranium decays and breaks down into a series of other products, one of which is radon. and that radon wiggles its way out of the earth into the air, and it breaks down quickly. 4 days to break down half of it. So why is this a health hazard? Well, the first part of that answer is that when a radioactive substance breaks down, what that means is that basically part of that element breaks off and flies through the environment. Some radioactive materials spit out an electron. You guys all know what electrons are. Super tiny subatomic particle. Some radioactive substances break down by spitting out what's called an alpha particle, which just is a fancy term for 2 protons and 2 neutrons. Well, that's what happens with radon. When it breaks down, it spits out this alpha particle, 2 protons and 2 neutrons, into the environment. That alpha particle isn't huge, but it's big enough that if it intersects with some of your body tissues, it can harm them. It can damage your cells. So that flying alpha particle going out in the environment, if it happens to hit you, it can damage your cells. So this gas radon, produced by the breakdown of uranium, rises to the Earth's surface. While it's rising, some of it breaks down by spitting off this alpha particle into the environment. It is a health hazard because of the way we live today. This is a really bad diagram. Pretty sure there are heavy amounts of beer being consumed when I put this together. But let me walk you through it. So this horizontal line right here in the middle, that's the ground, okay? So everything below the ground surface is where we have rocks and soils. And if you happen to have granite, granite's going to have uranium. Uranium's going to break down into radon. Radon's a gas. It's going to want to rise up, and it does. And when it hits the Earth's surface, the wind will just blow it away. But we're humans. We live on the Earth's surface. And what we do today that we weren't doing hundreds and thousands of years ago is we're making really good structures to live in. Okay, so here is a house here on the left. It's a well-insulated house. Why would we want a well-insulated house? Why do you insulate anything?
Your house stays cool.
Yeah, you want to keep, my dad used to say, he wants to keep the bought air in, right? So in the summer, got air conditioning going. You don't want to just open all your doors and let all that out. You want to keep that in there. You want to keep it cool. And in the winter, like days like today, you want a well-insulated house so that when you heat up the air, it doesn't escape and you have to heat up more. So the more well-built a home is, the better insulated it's going to be. But remember, the idea behind insulation is keep the air in. And what happens with radon is it rises up to the Earth's surface. If there's no house, the wind's just going to blow it away. But if there's a house above it, that radon's actually going to wiggle its way through the concrete base of your house, the foundation or the basement. It'll look for cracks, or it can even just move through pore spaces. It can come in through the water. It can come in a number of ways. But once it's in your house, it stays in your house because you have a really well-insulated house. None of it's escaping. So what's that going to do to the radon levels over time? They're going to go up. Over here on the right is a more poorly insulated house. Poor professor might own a place like that, maybe not as well insulated. So you're getting more exchange of air with the outside environment. And what this is showing is that some of that radon can escape through the poorly insulated walls and rooftops, and the levels won't be quite as high. Okay, so that's how we raise the radon levels in our homes, through insulation. Here you're being a good, environmentally conscious person, right? You don't want to spend extra money on energy to heat the air up in the winter or cool it down in the summer. So you put in extra insulation to cut down on your utility costs, good for the environment, you're doing everything right. The problem is you're also doing everything wrong with respect to radon. All the things that are good about keeping the air in is also really bad when it comes to radon itself. So the levels of radon start to increase. Here's a little diagram. So you've got the bedrock. Radon rises up through the cracks. If you happen to have a home nearby, it can get into the water. It can come up through the hole where your sump pump might be. It can come up through any cracks or crevices. Generally what happens is radon levels tend to be really bad in basements where the radon first enters. And as you go up to subsequent floors that are higher up, you get a little less radon. It takes more time for that to go up. But you live here, right? How much time do you spend in your home every night sleeping? 6, 7, 8 hours, right? What do you do the whole time you're sleeping? You're breathing, right? You breathe in, you breathe out. You breathe in, you breathe out. Every breath you take probably has some radon. You breathe in the radon. Does your body use radon? You breathe it back out, right? No harm, no foul. You breathe in the radon, you breathe it out. Breathe it in, breathe it out. Every once in a while, though, you're going to take a breath, and because that radon has a really short half-life, what's that radon going to do in your lungs? It's going to break down. It's going to spit out an alpha particle into your lungs, and it's going to damage your lung tissue. And it's every bit as damaging as smoking. Okay? It will damage your lungs just like smoking will. So a well-insulated home, especially if you happen to be sleeping in the lower levels, can be really bad for your health. And I'll show you just how bad here shortly. So here's a map of the US, color-coded to show the risk of radon in each area. Yellow areas are pretty low. We measure radon in a unit called a picocurie per liter. So a liter, quart, picocurie is a measure of radioactivity. So it might be hard to see, but this yellow area are places where the air in homes tends to be below 2 picocuries per liter. 2 picocuries per liter is pretty safe, okay? You're not going to suffer much lung damage if you breathe in air that has 2 picocuries per liter. So you can see the south and southeast part of the US. Really low radon levels. These people do not have to worry much about radon. Orange areas, 2 to 4 picocuries per liter. 4 is like the safe limit. You don't want to be over 4, okay? So these orange areas are approaching the limit, but they're still okay. Now the red areas, on average, have levels that are higher than 4 picocuries per liter. So higher than the safe minimum. It's a pretty big part of the country, isn't it? And look at Colorado. Look at where you live in Colorado. You're in the red. You have high radon risk. And if you look, you can see that a lot of the red areas are in the Intermountain West, where the Rocky Mountains are. You also see it in the Appalachian Mountains, where you get lots of granite and mountainous areas. There tends to be a fair bit in the Midwest as well, because just the rocks and soils there have lots of uranium. So we are in a high radon risk area right now. You are, I am. So I can tell you a couple of personal stories. I used to live in the Black Hills of South Dakota, which is right up in western South Dakota in that orange area. But my particular town always had really high levels of radon. And I bought a house, and our bedroom was in the basement. And I know about radon, so I was a little bit concerned about it. So you can buy radon measuring detectors at like Home Depot or Ace Hardware. They're like $20. I'll show you what one looks like in a minute. It's just a little canister. You put it in the corner of your room, and it actually measures the number of alpha particles that zoom into it. So it's a measure of how much radon is there. So I put my little radon detector in the corner, usually leave it there a few days, and then you send it into a lab, and 4 or 5 days later they tell you what the amounts were. Well, mine was 12 picocuries per liter, which is 3 times the safe limit. But at 20 picocuries per liter, it gets really, really dangerous, and then they want you to take some engineering approaches to exchange the air in your home. So I was below the really bad limit, but above the safe limit. I care about my health. I don't really want extra lung damage. So what do? You know, you're going to spend $10,000 for a system. I didn't have $10,000. I was a young professor, no money. I couldn't afford a radon air exchange system. And I wasn't at that level anyway, but I was higher than I wanted to be. So what do you think I should do? Is there anything I can do? Open the window. This is western South Dakota. I had my window to my bedroom open all winter long. 40 below zero, I had my window just cracked so it would give fresh air. I mean, it sort of defeats the purpose of having a well-insulated home, right? My utility bills were higher, but that dropped my radon levels down to about 3. So it worked. I just exchanged the air, but I had to pay for it with higher utility bills. When I moved to Fort Collins 13 years ago, I put a bid in on a house over in Fort Collins, and in Colorado, if you're selling a home, you have to have a radon test because of what the map is showing. We have high radon risk. So I had them do a radon test, and it was, I think it was 24 picocuries per liter. So it was above the limit that's considered safe, and then you're supposed to have a air exchange system put in, which can run you $6,000 to $20,000, and I just didn't want to deal with it, so I passed on the house. I pulled my offer and bought a different one where I think my current home had a measurement of about 3 picocuries per liter. So I can live with that. I like cold air anyway, so I always have my windows open. I got used to it being in South Dakota. So and now my bedroom's on the top floor too, so everything's going better for me now. But those are the things you have to think about. And I'll show you just how bad this can be. This is a chart that equates radon gas levels with the damage caused by smoking. Remember the place in Fort Collins that I wanted to buy, 20-some picocuries per liter? That's the equivalent of smoking 40 to 60 cigarettes a day. 1 cigarette every half hour. That's pretty much chain smoking. That's how bad this stuff can be. Even 10 picocuries per liter. 20 cigarettes per day, 1 per hour, even while you're sleeping. This is serious stuff. This is something that if you are currently living in an apartment or dorm room and it's in the lower levels, ask your landlord to have it checked. Make sure it's okay. Because do you want this? Just think if you're a smoker, okay? If you are a smoker and you're smoking 10, 15 cigarettes a day, depending on the air you're breathing, you might as well be smoking 4 or 5 times that much. I know even smokers are concerned about the damage that is being caused to their lungs, and yet on top of it, you're getting all this extra. So this is something to take really seriously. Like I said, you can get these radon gas detectors. It's a first alert one. You can buy it at Lowe's or Home Depot or Ace Hardware. And again, it's a little canister. I think I have a picture of it. Yeah, there it is. Little canister, little slots on the side. What that allows is for these alpha particles that are being emitted from the radon gas to zoom through the environment. Some of them will go through the detector. Send it off to a lab. They look at how many times the detector's been hit by an alpha particle, and they can back out just what your concentration of radon is in your house. So you just fill out your information, put it in a little box, put it off in the mail. 4 or 5 days later, they send you an amount. My wife has some apartments up in Laramie that she rents out, and she bought a fancier one. I think it was like $300, but it's a little portable device. You can just move it around and it gives you a little readout right on it. So she knows what the radon levels are in the homes that she's renting out. She's actually a good landlord. She doesn't want her tenants to get massive lung damage. And she knows too that if her homes have high levels of radon, she's going to have a hard time selling them later, because a lot of people are looking at this now. So she'd rather know and get it fixed rather than deal with it later. So hopefully you guys have good landlords that would be willing to do this. So if you look close, especially if you go over to Fort Collins is pretty bad with radon. Some neighborhoods is really bad, some subdivisions. You'll see these PVC structures on the side of the house. That's part of a radon gas venting system. So what it's really doing is it's sucking air mostly from the lower levels out of the house, and then air from outside is being brought in. So it's an air exchange system. And as you can imagine, this can get pretty expensive. You know, this is $5,000 to $10,000 for an average home. Before I came to Colorado, I had a professor job up in South Dakota, and we had a daycare on campus for the workers, and it was in the basement of one of the dorms. And when the whole radon thing kind of came to light 20, 30 years ago, they decided to get the radon levels checked in all the buildings, especially a dorm. And when they looked at the basement of the dorm where the daycare was, they were right around 20 picocuries per liter, really high levels. It cost the university $250,000 to retrofit in an air exchange system. So it can get really expensive. So something to think about. I am intentionally trying to make you uneasy and scare you because I want you to take this seriously. All right, I think we'll do one final one here. This is not a common problem, but I just sort of illustrate it. A lot of times we talk about problems that affect lots of people, and we ignore areas where few people live, like rural areas, but rural areas are important. People live there. It's where our food comes from. It's always been my big personal beef here in the US is that we don't pay enough attention to the farm areas that affect all of us. This is a problem that you don't see happening in cities, but it does happen in some rural areas. And sadly, it affects the youngest of our rural residents. It's called blue baby disease, and there's the official name of the malady up top. Methamoglobin, I don't know, you can try to pronounce it. Good luck. Say it fast 3 times. It is a disease caused by nitrate poisoning. Nitrate is a molecule that's really the primary molecule in all types of fertilizer. So if you buy fertilizer, it's usually ammonium nitrate. You may remember back to a domestic terrorist incident we had. Gosh, it's been, 20-some years now? Oklahoma City bombing. Tim McVeigh bought a bunch of fertilizer and turned it into a bomb. Ammonium nitrate. So this nitrate, there's lots of it in the environment. Cow crap, pig crap, crap in general has lots of nitrate. That's why we use manure as fertilizer. We spread it on fields because it has a really high nitrate concentration. So areas that have lots of farm animals have the potential to have lots of nitrate. And this disease, blue baby disease, is a disease caused when you get too much nitrate in your body mistakes it as oxygen, and it picks it up like it's oxygen and delivers it to your cells, and your cells can't use it. So the blood thinks it's oxygen, the cells know it's not oxygen, so your cells are then deprived of oxygen. And basically you start to suffocate. Hence the name blue baby disease. What happens are This tends to affect people with either underdeveloped or damaged respiratory systems. So the really young or the really old. And babies are especially sensitive to this. So what I'll do here is I'll try to draw this out for you. Show you what happened. So we have a farm, and this is looking from the top down. So this right here, this H, that's their house. They had a house in one corner of their farm, okay? This example was from a hog farm in eastern South Dakota. And they had pigs. They actually had 2 areas on their farms where they had lots of pigs. So over here, you had lots of pigs. And over here, you had lots of pigs. If you've ever watched pigs, they do 3 things all day long. Want to take a guess what it is? They eat, they drink, they crap. Pigs do all 3 of those things really well, okay? So these areas, if you've ever been to a pig farm, they are not the nicest places in terms of, you don't want to wear your nice shoes, right? So these areas right here, lots of pig crap, just enormous amounts, okay? That stuff soaks into the ground, okay? So all the nitrate in the pig crap is going to soak in the ground. Well, this is a farm far away from a city, needs water. No rivers nearby. If you're out in the rural part of the country, there's no stream, no city services, where do you get your water? You get it out of the ground. You have to drill a well. So drilling a well is expensive. It's about $20 a foot to drill into the ground. Now, if you have to go down 600 feet to get water, you're looking at a really expensive well, $12,000 or more. How many wells is a poor pig farmer in eastern South Dakota going to have? You have 1 well, right? And it's got to give you water, and it's got to give your pigs water. Where are you going to drill your well? Where would you drill your well? Now that you've been hearing this for a little bit. You don't want it by the pigs, right? Yeah, because it's going to soak in the ground, potentially contaminating the water you're going to suck up. These people didn't know about this. So if you don't know anything about this, where are you going to put your well? They decided, we're just going to put it in the middle. And then we can run pipes from it to the house and to the 2 pig farm areas. So they put their well kind of right in the middle where X marks the spot. And it was too close to the areas that have pigs. So the water had really high amounts of nitrate. But nitrate is odorless, tasteless, colorless, can't see it. So they were just drinking the water, had high levels of nitrate. The adults were fine. They had well-developed respiratory systems. They had a baby, though, and the baby got sicker and sicker, and they took baby to the doctor, and doctor looked into everything imaginable. Baby just kept getting worse or worse, and one morning the baby turned blue and died. And it was only later that they found out it was because of nitrate poisoning. So it's not common, but in certain areas, especially rural farm areas, it's a real concern. So these are just a few examples of where trace elements can really affect the residents when they are present in high doses. This last little bit here, so those are really clear examples that I gave you earlier. Radon, blue baby disease, iodine, where the health issue is clear. There are a lot of other health issues, though, where the role of trace elements isn't as clear, but is clearly a factor. One great example is that if you look at heart disease rates in the United States, they tend to be highest along the east coast of the US. New York, New Jersey, lots of metropolitan areas out there. And they tend to be lower in the Midwest. Go to places like Iowa, Nebraska, heart disease rates are much lower. Now, why is that? Well, there's a lot of potential reasons and probably a lot of potential factors. Stress levels are different. If you live on the hustle and bustle of New York City, that's a much different lifestyle than living in rural Nebraska. Much higher stress. And we know stress can lead to heart problems. Diet is different in those areas. Even genetics are different. Maybe not so much today, but even when I was growing up, if you think about how the United States was settled, it was settled by immigrants, right? We had lots of immigrants coming in settling. So let's say you lived in Italy and you wanted to move to the United States. US is a big place, right? Where are you going to go in the United States? You know, you got to have a plan, right? I'm going to go to the US and I'm going to live the American dream, but where am I going to live in the US? Where do you think you would live if you were from, say, Italy? What would you look for? So you'd want to go somewhere where there's jobs, right? So, but lots of big cities have jobs. I could go to Miami, or I could go to New York, or I could go to Chicago or Milwaukee. Which of those areas? What else might you look for as a second tier deciding factor?
So probably how close everything is to you.
How close everything is, but you're Italian, right? If you move to another country, you're Americans, right? You speak English. You might want to be with people who are like you. So you're going to look for Italian communities in the US. And you might find one in New York, but you might not find one in Miami. And if you look at like Milwaukee, Wisconsin, tons of people from Poland there. A lot of folks from Poland who immigrated to the US knew that, hey, Milwaukee's where everybody from around here moved to. I'm going to go there too. And remember, genetics, you kind of have similar genetic makeups in different places. So in the US, the East Coast settled a lot by Italians,